Hello guys, welcome to my new YouTube channel. Here we are going to see about the Agile solid principle. The definition of Agile solid principle is Agile programming is based on developing the software product in small incremental blocks. When the client's request and the solution is offered by a programmer, a progress simultaneously. Agile programming is based on a close relationship between the final quality of the product and the frequent deliveries of the incrementally developed functionalities. Next, we are going to see about the solid principles. There are 5 solid principles, namely single responsibility principles, open closure principles, Lisco substitution principle, interface aggregation principle, dependency inversion principle. In the upcoming slides, we are going to see about definition of every principles and example for each principles. Let me see the principles. Single responsibility principles, SRP. In the SRP context, responsibility can be defined as a reason to change. When the requirements of the project modify, the modification will be visible through the alteration of the responsibilities of the classes. If a class having several responsibilities, then it will have more reasons to change. Having more coupled responsibilities, the modification of a responsibility will imply modification on the other responsibility of a class. This correlation leads to a fragile design. Then we are going to see about the example of SRP. Here class phone was declared. This example is based on abstract method. You all already know about abstract. Abstract means only declaration and no definition. This example is based on the abstract method. Next, we are going to see about the open closure principle, OCP. When a single modification on a software module results in the necessity to modify a series of other modules, the design suffers from rigidity. The OCP principle advocates design refactoring so that further modification of the same type will no longer produce modification in the existing code, which already functions. Instead, it will only require adding new modules. And then the abstract class abstract server was introduced, and the client's class uses this abstraction. However, the client class will actually use the server class, which implements the client's interface. If in the future one wishes to use another type of server, all that needs to be done is to implement a new class derived from the client interface class. But this time the client does not need to be modified. Then we are going to Lisco substitution principle, LSB. In language such as C++ or Java, the main mechanism through which abstraction and polymorphism done is inheritance. In order to create a correct inheritance hierarchy, we must make sure that derived classes extends without replacing the functionality of the base classes. In other words, the function using pointers or reference to the base classes should be able to use instances of the derived classes without being aware of these. Contrary, the new classes may produce undesired outcomes when they are used in the entities of already existing program. Example: here we declared class shape. They also declared public void get size and void get set size. In this, we can set a size as a double size in the function. In the parenthesis, they are given a double size and get size, and they are giving double and size, private double and double m size. This is example for already we have seen LSB. Next, we are going to see the interface segregation principle. The principle stresses the fact that when an interface is being defined, one must be careful to put only those methods which are specific to the client in the interface. If in an interface one adds methods which do not belong there, then the classes implementing the interface will have to implement those methods too. We have seen the first example in the abstract method, in which only declaration definition, but in this for those declaration here the definition are given and initialized values have been set. Next, we are going to see about dependency inversion principle, DIP. This principle enunciates the fact that the high level modules must be independent of those on lower levels. This decoupling is done by introducing an abstraction level between the classes forming a high hierarchy level and those forming lower hierarchy levels. And thank you for watching my video. Give support, subscribe.